Well, I'm Richard Boyd, founder and CEO of Ultisim here in Chapel Hill, North Carolina. Now, my team has been building machine learning and simulation systems at scale for a long time. Today, we're working in healthcare and the Department of Defense, as well as in education, and you can see some of our background here. But going all the way back to 2009, while I was running Lockheed Martin's virtual world labs, I was summoned by Alex Kipman, who was running Microsoft Research Labs at the time in San Francisco. And that's when I really became aware of and really got religion on machine learning. At that time, for the Microsoft Connect system, uh, we spent over 224,000 hours of compute time just to teach a system what a living room was. What's the difference between a cat and a dog and a table and a chair and a plant, and how to use the human body as an interface. So we've come a long way since then, but that's when I first brought that capability back to Lockheed and started working on everything from F-35 manufacturing to design of the F-35 helmet and a bunch of other applications. It really was the new button on the calculator for us. So I also have been part of big exercises, war games, and this is an actual war game called The Force of the Future. I'm there with Doug Lennett on my right, who really influenced our team a lot on the whole concept of knowledge graphs, which we still think is incredibly important for any AI implementation. Having, if you hear about context, engineering, that starts with the knowledge graph. So we're still big believers in that. On my left is Alan Kay, of course, from Xerox PARC, Michael Jones from Google, and my colleague David Smith from Ultisim and from Lockheed Martin. Now, we've been looking at this thesis for a long time, the idea that everybody should be trying to figure out what's the right balance of human and machine intelligence, effort, and attention. Those three things that I've been preaching about to Joint Forces Command for 15 years now with my Simulation Century event at Mod Sim World that's coming up again here in August in Alexandria. I hope Erica and all of you, I'll see you there. But that's the thesis. My first article about this was in TechCrunch in 2014. So that's how far back we go as a team. We also helped NCI, who's now called Empowered, AI Empowered or Empowered AI or something like that, with my company Tanjo, win an $800 million contract, one of the biggest, if not the biggest AI contract back in 2021. Things have evolved a lot since then. Of course, we had that big bump in the night in December of 2022 when everything changed with generative AI. And I want to talk about what the systems architecture rules that are really hard won that we've learned over 60 deployments in major enterprise environments as well as government and other areas that we would like to pass on to the CDAO. And really, we're eager to help you guys see what we've learned and how we can provide that guidance to the rest of the Department of War and other government institutions, certainly. But it starts with these three things. It's the idea that with the data fusion plane, which is based on the DARPA global data plane and work done at Berkeley on the TerraSwarm project, that don't make a big data lake. That never works. Data lakes just don't work. There's a lot of very good reasons, as you guys know, for why data is left where it is, and all of its, you might call them silos. At Lockheed, we called them cylinders of excellence. But all these different places, it's got to be where it is for permission reasons, but just context usually. So leave all that data where it is. Our data fusion plane creates the narrow waist for that data and prepares it so that AI and digital twin-like applications can take advantage of it. The other thing we think is critically important that, we've been up to the Hill several times talking to Congress on this, is that you can't treat machine learning as normal enterprise software. It's way more powerful, way more intimate, and needs special care. So we really think whenever possible, it should be localized. You should not trust systems like software as a service type systems out there where you're uploading your information, no matter what. I don't care who it is, Microsoft, OpenAI, Anthropic. They're going to promise that they're going to care for your data, not let it out, and not ever use it in their training. I don't trust that. I don't think the government should trust it either. Nobody who's been in this enterprise or in this environment for a long time trusts that idea. So we don't think the anybody in the Department of War should either. The last thing is critically important. I'll try to spend a little more time on that. Is this thing we built called Veritage. It's built on blockchain-like concepts, but it's about information. It's about chain of custody for all of the information that that goes into that is in an organization, all the way down to the granular level. And we'll talk about a NASA application we did that's 270 petabytes of information, where we combined data sources from a bunch of different data archive centers, or DACs they call them, into one central area where we can now use that for scientific research by combining all this information in one place. That's creating what we call now the new scientific method. Very excited about that, but of course, amazing applications in war games and in the Department of Defense. But it's dealing with these two major issues that in the white paper that I've sent you, where I'm talking to about this at NATO and at ModSimWorld and at ITSEC, is about AI contagion. This idea that information gets processed or mediated by AI, and what comes out is just put back into the system and not validated and verified. Something that we really know about in simulation is critically important. And the idea of what I call an epistemic airlock, a place where anytime AI mediates or touches data, it goes into that airlock and must be validated before it comes back into the system. So we'll talk a little bit about that. And here's kind of what the data layers look like, and what we're really offering here for you, for the whole industry, is a systems architecture design that we think is optimal for any AI deployment, any digital twin deployment. And again, there's all these lessons we've all learned from legacy designs in government builds that are very expensive, and where everything's done with monolithic coding. We have a whole entire different approach where we have really quick deployments. And I'm going to show you digital twins around the F-16, around satellite data, space information, NOAA sensor data, and even hospitals, where we've combined a lot of information and deployed things in less than 90 days. And that, of course, translates into great savings for the government and of course, all the other benefits that we've just talked about. Another core concept that we believe strongly in is generative AI alone is never sufficient. And anyone who's deployed a lot of these systems knows that real hardened kinds of applications always include what I call the old AI, which is just the symbolic rules-based systems and Doug Lennett's knowledge graphs, combined with the interpretive stuff that we see with generative now, with that epistemic airlock and Veritage provenance or chain of custody verification. But that combination of things is how you get really good AI applications and digital twins. Again, this just describes the problem of, if you understand how these, and we've trained a lot of systems in our 15 years working with this from the ground up, even before the white paper, Attention is All You Need, came out in 2017. We were training our own systems, and that it is a lossy compression of whatever data was provided. And then there's that issue of hallucination or misinterpretation that goes into an output, and that output ends up becoming part of the lore or the organizational knowledge, and it's not validated, not verified, and it pollutes everything after that, and can result in, especially in the life and death environments we're dealing with, like whether it's hospitals or the network-centric battlefield, it's incredibly risky to do this. So instead of just downstream copying, we go all the way down to the sort of granular level, and that's what NASA calls them, granules, where we really track every single component. We see that has it been altered, has it been changed by AI, and does it need to be verified by a human before it becomes verified. This is an image of the airlock again. More stuff about Veritage. Again, I look forward to talking in more detail about this, and you'll see this in the white paper. But we at Ultisim definitely look forward to bringing all of these benefits to bear with our deep experience in this space. Even though we're a small company, but we're eager to make sure that decisions aren't being made, and that's what I worry about. Big decisions being made structurally about how these systems are deployed without great thought about these important lessons learned. So, and that's really the closer right there. Know whether a machine touched it, know which humans stand behind it before you start building big decisions. And again, I look forward to going through some of these case studies like we did with the F-16. Again, less than 90 days. We worked with Wright-Patterson, pulled in SysML files and data about the F-16 over 3,200 independent data sources about how much amperage does that system take? How does it talk to another system? And you see that there's an AI interface, an agent that is only talking to the SysML data, the .mlpf information about emission needs, information about this aircraft. So if you make a change, it can actually tell you how the rules apply and shorten the mission needs analysis of that aircraft suitability from 30 hours down to literally minutes. And it deploys in a web browser, by the way, if I didn't mention that. And instead of being millions or tens of millions of dollars for a digital twin, we're talking, six figures. We've done the same thing with satellite and ground stations. We're tracking all 10,000 or more Starlink assets, working with our partner Interion. And again, with an AI interface that helps you adjudicate or go through all the information that's being provided. This is the NASA application I'm talking about that I'll be interviewing some NASA folks at my Simulation Century event at Mod SimWorld this year, where we've done something extraordinary. We've in less than, I think it's more like 120 days, we've combined 270 petabytes of data, fused it into one queryable sort of data set that now you can have. And one of my favorite things here is an automatic hypothesis generator using AI, where the AI comes up with new ideas. And that's why we call it the new scientific method, that it proposes to the scientists by cross-pollinating all this data. And then you can really come up with new discoveries. So it's really, really exciting stuff. Same thing for NOAA. All of the weather data as they go digital across all the 170 or so weather stations across the country. With Space Force, we're talking about really rapid deployment of new wargaming type platforms that are, again, lightweight, data infused, using the data fusion plane, but also have the AI interface that let us practice things like, in these new environments about what is the telemetry, what are the new physics required, and how are we going to deal with some of the logistics and contested environments that we may be dealing with in space, in the cislunar environment especially. And then in healthcare, we're out to solve some really big problems, and we've already demonstrated this with Cleveland Clinic, taking all of their data about processes and patients and drugs and devices and environments in a hospital environment, and being able to simulate everything within it, either looking at the past, what's happening today, or looking into the future. And again, with thoughtful local AI application of it. So look forward to talking further and sharing all these ideas with all of you at CDAO. Thank you for your attention.